Hello and welcome to 4.3, Graph with Intercepts. The three objectives here are to identify the x and y intercepts on a graph, find the x and y intercepts from an equation of a line, and graph a line using the intercepts. Let's understand what this language means, intercepts. Okay, in plain English, intercepts means to cross something, right? To cross. So a police interception and things like that, right? Now, when we talk about intercepts of a line, the line crosses either the x-axis or the y-axis at some point, and not always, but most lines do. And so we have to find where they cross or intercept the x-axis and where they cross or intercept the y-axis. So the points where the line crosses the x and the y-axis are called the intercepts of a line. As you can see in this example, right? So we have the line, which is our graph, right? The graph intercepts the x-axis, okay? I call it the x-intercept, INT is short for x-intercept, okay? And we have the y-axis, the graph touching the y-axis up here. That's the y-intercept. So here is a slanted line, right? All slanted lines will do that, okay? If it's a horizontal or a vertical line, as you can imagine, it will only cross the y-axis or the x-axis, depending on what line it is. But every slanted line will have x-intercept and y-intercept, and therefore these are the slanted lines we're considering. Okay. If you look at the next one, the second figure, the equation is 3x minus 4y equals 12. When you graph that, you will see that the x-intercept happens at 4, 0, and the y-intercept happens at 0, -3. I would like you to observe the two graphs and see what is common in the x-intercepts. Well, the obvious common thing is they both cross the x-axis, but that is the definition, right? That is why we look at that point. But if you look at the coordinate, right, both the x-coordinates have the y part of it as 0. Can you see that? The y is a 0, the y value. And if you looked at the y-coordinates, it's the other way around. They both have the x-coordinates as 0. Yeah? And that is what is being captured here in this table on the left. The definition here says the x-intercept is the point a, 0, where the line crosses the x-axis. The y-intercept is the point 0, b, where the line crosses the y-axis. So as you can see, if it is x-intercept, then y is 0, right? And if it is y-intercept, then the x-coordinate is 0. That's the key idea, and this is a property, so it's going to have, recur in this concept everywhere. Whenever we talk about x-intercept, think y as 0. When we talk about y-intercept, think x as 0. So here's the problem. They want us to find the x and the y-intercepts on each graph. So let's look at graph A. X-intercept means the point where the line crosses the x-axis. So this is where it crosses, and there's only one x-intercept. If you think of it, it's a line, right? It only crosses the x-axis at one point. It's not going to turn and come around to hit it again on another point on the x-axis. Only a curve can do that. A line cannot do that. So there is only one x-axis. And the coordinate for that is 4, 0, as you can see. And we do expect the y part of it to be 0. Okay? And then the x-intercept is here. That's the point where the line crosses the y-axis. And that is 0, 2, as we expect. For y-intercept, the x-coordinate is 0. Okay? So maybe I'll just write here x-int as a suffix so you can see that. That's the x-intercept, and this is the y-intercept. Okay? Okay, how about here? Well, the x-intercept is visible here. So that's going to be 2, 0. That's my x-intercept. The y-intercept is not nearly touching, but that's where the graph ends. So actually that is my y-intercept, which is 0, -6, which is the y-intercept. Okay, and then we have this point. -5, 0 is the x-intercept there. It can happen any side of the x, right? Not necessarily the positive side, the negative side of it as well. And here we have 0, -5. This is my y-intercept. It crosses the y-axis. This is the x-intercept. Okay. Again, let's remember these two big themes are happening here. X-intercept means the point where the line crosses the x-axis. Y-intercept means the point where the line crosses the y-axis. If you're talking about the property, x-intercepts always have the y-coordinate as 0, and y-intercepts always have the x-coordinate as 0. Okay. That's the whole idea here. Okay. So if you are given the equation and you're asked to find the intercepts, you don't have a visual of the graph, right? So your only chance is to fall back on the definition. The definition says if x-intercept is what you're trying to find, then you have to set y as 0. And if you're looking at the y-intercept, then set x as 0. So that is what we're going to follow in our next problem. Okay. Okay. Find the intercepts of 2x plus y equals 6. I put the table because we could do this by table as well. I'm also going to show you how we do it by algebra. Okay. But remember, if you want the x-intercept, you want your y as 0. See, I'm plugging in y as 0. I'll maybe use red so it stands out. Okay, that is my x-intercept because my y is 0. If you want your y-intercept, set x as 0. Okay, that's it. Well, for a line, we like to have 3 points so that we could just cross-check it. So if you're graphing this, you can choose one more point. But they didn't ask us to graph, they just asked us to find the intercepts. So I plug in 0 for y in the first time and plug in x as 0. So I'm also going to show it to you, of course, algebraically here. Okay. So I'll just say to find x-intercept, set y as 0. Okay. This means in your equation 2x plus y equals 6, I will have to plug in y as 0 because you're trying to find x, because that will give you the x-intercept, right? So y is 0. So that is 2x equals 6. The 0 term goes away. Get x by itself, divide by 2. This implies x is 3. X is 3, okay? But it's an x-intercept, so write it as a coordinate. X-intercept is 3, 0, because we already set y as 0. So that is basically what you would do in a table, right? You will plug in the value you have in the table. So we plugged in 0 for y, and we got the corresponding answer for that for x as 3, which is totally fine. You can plug in for x and get your y, or you could plug in for y and get your x. And then we have to find the y-intercept. It's the other way around. We now set x as 0. That means implies, right? So this implies 2x plus y equals 6. And it's the same equation, right? We're drawing the same, looking at the same line and seeing where it crosses. So your x now takes the value 0. 2 times 0 is 0. That simply gives you y equals 6. But write it out as a coordinate. So y-intercept is 0 for the x, 6 for the y. In the table, you can come back and plug in as 6 for the second row. So your x-intercept comes out to be 3, 0. The y-intercept is 0, 6. It makes sense because your y is 0 for the x-intercept and the x is 0 for the y-intercept. All good. We're going to need this for the next problem. This concept, I mean. So this time we have to graph. Okay, graph Negative x plus 2y equals 6 using the intercepts. Okay. Well, we've seen that we have to plug in y as 0 and x as 0 each time to get the other variable. So go ahead and here plug in. So I'm going to do the calculation here. I wish it was a bigger box. Let's see. I think we can manage. Plus 2 times 0 equals 6. Plug in the 0 there. So that will be negative x equals 6. You don't want the negative x, so divide both sides by -1, which implies x is -6. Okay. I don't have much room, so by this time you are pretty familiar with the equations. You know how negative x became an x. The negative went to the other side. Okay, so the coordinate for that will be -6, 0. That's my x-intercept. And here, it's the same equation, but I'm going to plug in for x. And my x is 0. So that goes away. You're simply left with 2y equals 6. This implies when you divide both sides by 2, you get y equals 3. And 0, 3 becomes my y-intercept. So I'm going to plot these 2 points in here and connect them to get my line. Okay. -6, 0 is way here. 0, 3 is up here. X-intercept must be on the x-axis, y-intercept must be on the y-axis. So no doubt about that. Ideally, your line should stay inside the graph. Mine is stretched out a little bit because of my circumstances with the touch screen and the tablet. But when you're doing it on paper, it should not be a problem. All right, we are given the equation, so give the name to your graph. 2y equals 6. Let me put the coordinates. This was -6, 0. This was 0, 3. All right, now to make sure that we got it right, you can go back and check your calculations. Another way is to bring in the third point, okay? Give your own value for x or y, and then you can find your third point. So I'd like to, let's plug in, say, 1 for x, okay? 1 for x. So negative, you could have plugged in some for y as well, but I'll just do this. 1 in the place of x. Okay. So it's going to be a little tight, so you can't see all the steps, but you're going to work it by yourself as you're watching this video, right? So -1 plus 2y equals 6. That's what I have. I need to get rid of the -1 to the other side, so I do +1 on both sides. That gives me, bad choice. I just chose a 1, which did not give me as I desired. Okay. For that matter, I'm going to change my mind now, okay? Because the whole point is I'm trying to see it line up. I can already see that we're going to get a fractional answer. So it's not wrong, it's just that we can't graph it. Okay, so I'm going to use a 2. So negative plus 2y equals 6. Let's plug in the 2 there. That should work. -2 plus 2y equals 6. So you're going to add 2 to both sides. Sorry, it's all tiny there, but I'm trying to squeeze it in. 2y equals 6 plus 2 is 8. That means you divide both sides by 2, y equals 4. So the third point I get is 2, 4. If 2, 4 lies on this line, I know that I did it right. Okay. This is why we need to do fine graphing. Mine is a little, what do I say, sloppy, because I couldn't adjust it exactly. But let's see. So let me use maybe a different color for this. 2, 4. 2 and 4. It's right there. It's slightly off because, again, of the disclaimer. 2, 4. But if you did use a ruler and you did a fine drawing, yes, it will look like, it will pass through 2 comma 4, it'll look exact. So 2 comma 4 kind of helped us to test that we did the other two things right. And with that, we come to the end of this section. We'll see you in the next video. Have a good one.